Assalamu alaikum. Hello. My name is Abdel Noor Boulsnan from Constantine III University in Algeria. Happy to present today my work entitled Do We Need Change Detection for Dynamic Optimization Problems? A survey. So firstly, we will start by presenting a general overview about dynamic optimization. After that, we will move to explain the problem statements and to raise the following question: what is the dynamic optimization problem? Next, we will talk about change detection and without change detection based methods. Finally, we end this presentation by conclusion and some perspective. So man seeks to improve his daily life. Man loves perfection. He always tries to minimize his expenses, his rent, or the consumption of his car. And therefore, man tends to want to maximize profits or equivalently to minimize losses. Optimization comes to make human wishes come true by modeling life problems in their mathematical functions, the aim of which is to provide a quality solution in a reasonable time. Nowadays, optimization has become a central subject in operations research. The number of decision support problems that can be formalized in the form of an optimization problem being in strong growth, whether in engineering, industry, transport, or other sectors. Mathematically, optimization is the search for the variables values, or we can call that decision variables, that minimize or maximize a given function, or what is called the objective function. If the variables of these function are forced to evolve in a certain part of the search space, we will therefore have an optimization problem in their constraints. Otherwise, we will have an optimization problem without constraints. Since optimization deals with the problem at a given point in time, this kind of optimization is known as a static optimization problems. Up to this point, it is admitted that optimization really helps to solve very difficult situations in various fields by offering methods of resolution adapted to each problem. The peculiarity that these methods have been adopted to deal with problems at one point in time is what we call static optimization. However, in reality, we operate in environments which are dynamic, which change over time, and therefore the optimization must take into account the dynamic nature of these environments. For example, as we see here, we have a problem. A static optimization is powerless in the face of real-world problems that change over time. We can see this in several real situations. If we take a few examples, the align trajectory planning problem, as here for this car. Let's repeat this. So the align trajectory planning problem is an important problem, especially in the world of industrial robotics, which consists in finding the shortest trajectory while avoiding dynamic obstacles. In this case, static optimization is really effective in front of static obstacles, but helplessly in front of dynamic obstacles that exactly simulate reality. In industry, we can see the dynamic task assignment problem, which consists of distributing a set of tasks over several machines so as to minimize the time required to process these tasks. The dynamic aspects in this problem can be seen in the fact that these tasks can appear or disappear at any time, and even machines can break down. So the dynamic optimization algorithm must find the optimal solution in each of these situations. Another similar example is the dynamic routing problem in mobile ad hoc networks. For this problem, routing plays an important role in various types of network. There are two main ways to route packets, unicast or multicast. So here, in this problem, So one of the most important characteristics in this network is the dynamic of the topology. It means a new node that appears, another disappear, a node or communication link that breakdowns. So all of these are problems, make these problems very challenging. Data streaming is a mechanism used to update data. It is mainly used to create applications that provide real-time experience, such as social networks or any application that requires a real-time notification system. This dynamism poses great challenges to traditional static methods, and therefore necessary adaptations must be made to be up to date with new technological developments. So what is a dynamic optimization problem? Mathematically, and by comparison with static optimization, a dynamic optimization problem is written in the following form. Optimize the objective function f, which can change over time at instant t, with constraints which can also change over time. The goal here, or the objective is not only to find the global optimum, but to follow it as faithfully as possible over time. The major challenges of dynamic optimization, you should know that the objective of dynamic optimization algorithm is to fall and not only to find the global, optimum, but also to follow it in the search space during the time. Next, for this, you must have a sufficient level of diversity throughout the search space. In addition, the algorithm must converge towards the overall optimum each time a change occurs in the environment, because the time between two successive changes can be costly and sometimes unknown. The problem of outdated memory. After an environmental change, the information accumulated during the run of algorithm, including the solution found and their positions, fitnesses, can become useless over time, and therefore they can mislead the evolution and prevent the algorithm from finding the new optimum. So you must manage all of these challenges in order to release and to construct new to resolve the dynamic optimization problems. The detection of change, this setup is carried out by introducing a procedure, external procedure to the dynamic optimization algorithm, which will follow a set of criteria in order to detect changes in the environment. Most dynamic optimization algorithms rely on this setup to react appropriately to future changes. So alongside the optimization process, change detection is very important setup to better respond to dynamic environments. Some dynamic environments can pose challenges such as noisy environments like here, or partial landscape changes. If you have just partial landscape that changes, and fast landscape changes. Therefore, dynamic optimization algorithms in such environment depend for their success on an efficient change detection method and an educated change reaction strategy. In the literature, dynamic algorithms detect change based on 4 methods. The first method is assumption-based detection. This method makes sense for solving only the academic benchmarks problems. So it's inefficient in front of real-world application, where the changes are often random or unpredictable. Secondly, we have behavior-based detection methods. By using these methods, there is no need for additional function evaluations, but Since behavior-based approach are mainly related to the algorithm used, they cannot be defined as specific. They can be defined as specific approaches, which means it is impossible to directly incorporate these approaches into other algorithms. Other famous methods is revariation-based detection methods. This approach is easy to implement and does not require elaborate statistical analysis, and it's more favorable when the change detection is more difficult. However, it assumes that there is no noise in function evaluation, which means it's not robust with all problems instances. The last method is hybridization based detection. This piece is its effectiveness. It is always suffering from the problem of high computational costs. So to avoid these drawbacks, a new initiative has been recently undertaken. This new idea consists of developing new algorithms that will be able to deal with dynamic environments adaptively without using any change detection schemes. In other words, solving doubts without using any change detection methods to deal with diversity loss problem and the audit memory problem. In fact, there has been much literature on the subject of diversity loss problem. Generally, this problem has been tackled with the ultimate goal to maintain population diversity without using any change detection mechanism throughout the entire run of the algorithm. On the other hand, the audit memory problem has been always solved using iterative reevaluation, which is computationally expensive. This problem may prevent the algorithm finding new optima and misguide the optimization process. So, and very little research effort has been devoted to solving this issue compared to diversity loss problem solving. Indeed, in the literature, the detection of change based on reevaluation considered to be the most used method. By examining 400 scientific papers related to solving dynamic optimization problem, it was found that 96% are reevaluation-based detection, and 2% are behavior-based detection. However, despite the efficiency of this method, they are still impractical in front of many difficult changes, such as partial, fast, and noisy environments. This table here shows the importance of the transition to thinking about a new class of dynamic optimization method that do not depend on knowing the point of change to deal with future environment. In other words, the kind of algorithm that do not require extra computational resources to know the change and do not care about where, how, or when future change will occur. By conclusion, many real-world problems are dynamic, require optimization over time because of the dynamic nature of the environments. In this paper, we have tried to provide a survey of the literature on various change detection-based schemes. We have also proposed new classification of change detection-based methods. Solving doubts without using any change detection scheme is an open research issue. Whatever the problem's characteristic and whenever the changes occur, this kind of algorithm is not based on the knowledge of the change point time to handle future change. For future work, it would be interesting to design new optimization algorithm that can dynamically adapt to change by maintaining diversity and remedy the problem of audit memory problem without change detection. Thank you for your attention.